Hello friends, I am Dr. Narayan Singh, Department of Mathematics, Janki Devi Memorial College, University of Delhi. Today we have discussed the topic analytic function in complex analysis. Basically before discussion the analytic function, we just know about the complex number. And complex number easily you can say understand the formation with two number, one is real and second is imaginary number like a plus ib, and from that journey we can start and go on. So next one, the introduction. Welcome to the presented analytic function in complex analysis. And the complex analysis deal with the function that involve complex number like a plus ib, where A is the real part and B is the imaginary part of that complex number. And analytic functions are fundamental concept of complex analysis, and they have numerous applications in the various areas of science and technology. Basically, we can say the starting of complex number with the analytic function. जो भी डिस्कशन होना है, जो भी बात करनी है पूरी कॉम्प्लेक्स एनालिसिस में, वो एनालिटिक फंक्शन को पर ही होती है. अगर कोई फंक्शन एनालिटिक है, then we can discuss anything in complex analysis, and function is not analytic, then I think there is no meaning for further discussion. So complex, before that we also go to some point of complex number, like a complex number frame with two components A and B. A is real part and B is the imaginary part, and the combination is called A plus of the form A plus IB is called complex number. The imaginary unit I is the value of I equal to square root of -1, and the I square equal to -1, or I equal to square root of -1. That is the generation or begin of the complex number of the form A plus IB. The complex number are represent the complex plane where the x-axis represent real axis and y-axis represent imaginary axis. And definition of analytic function. Analytic function is complex valued function that is differentiable at every point of some neighborhood of any point. That means if we are trying to find the analyticity of any complex number at any point, that at some neighborhood of every point, functions should be differentiable. If we have a single point in the neighborhood in that function is not differentiable, then you can say function is not analytic at that point. So analytic hona or na hona, it's all depend on the differentiability of the function at the every point of some neighborhood. Formally, function fz is analytic in a domain D. If a function is analytic throughout all points in a domain D, then we can say the function is analytic in a domain D. And it means we can say function is differentiable, means fz is exist. Analytic function also refer the holomorphic Cauchy-Riemann equation. That is another important topic or equation in the complex analysis that play a very important role for discussion the function is analytic or not. That is complex Cauchy-Riemann equation, and Cauchy-Riemann equation are essential condition for a function to be analytic, and that are called if fz complex function w equal to fz equal to u plus iv, then w upon w x equal to w upon w y, and w upon w y equal to minus w upon w x. These both equation or relation are called Cauchy-Riemann equation. These equation relate the real part and imaginary part of the complex function. Property of analytic function. Analytic function possesses several interesting properties, like the preservation of analyticity, means the sum difference product of two analytic functions are also analytic. Composition, the composition of two analytic function means function of function also analytic. And third one, derivative. The derivative of analytic function is itself an analytic function. And another important point in that discussion that stop to go further, that is singularity. If any function is not analytic, that will be because of analyticity. So means analyticity what? The function is not differentiable at that point. These points are called analytic function. Oh, sorry. Singular points, and stop to be analytic of any function. Example of analytic function. Some common example analytic function like polynomials in Z, like exponential function means e to the power Z, sin Z, trigonometric function. All these are some example that are analytic function throughout the domain. Some rational function can be written as fz equal to pz upon qz, where pz and qz are polynomial. The necessary condition qz cannot be equal to 0 for all z, for any z value of z. So this rational function is also called, can be treated as the analytic function. These are some basic example. Next one, contour integration and Cauchy theorem. मित्रों, जब हम फंक्शन को एनालिटिक या एनालिटिसिटी, इस पूरी प्रॉपर्टी को, इस पूरे करेक्टर को थॉरोली डिस्कस करते हैं, तो नेक्स्ट वर्क स्टार्ट होता है कि इस एनालिटिक प्रॉपर्टी का यूज क्या करें. सो दैट, या इसका नेक्स्ट स्टेप क्या होगा, एंड दैट इज द इंटीग्रेशन ऑफ कॉम्प्लेक्स फंक्शन, दोज फंक्शन विच आर एनालिटिक. वी हैव डिस्कस इन स्टार्ट कि फंक्शन ओनली दोज फंक्शन used in further discussion that are analytic. So the function are analytic at some point or with some problem, and the integration of that function can be treated, can be deal multiple way, and one of that is called contour integration, and second one is Cauchy theorem. So contour integration is the line integration that involve the value of function along a closed curve. And Cauchy theorem states that a function fz analytic inside and on a closed contour C, then the integration of that function will be 0. So this help very important. This play very important role. Second property are means Cauchy residue theorem. Sorry, Cauchy-Gaussian theorem, not residue theorem. From that theorem we can solve infinite number integration in instant way. If you find function is analytic inside and on a closed contour C, then the integration of that function will be 0. Nothing to solve. And third point is the powerful theorem has play important role in the complex analysis. And second, another most important theorem in complex analysis is residue theorem. And this theorem used when we find some singular point in the contour, and this theorem says the integration of that function along this contour is equal to 2 pi I and sum of the residue. Means जो भी singular points हैं उन पे residue निकालो, उनका total कर 2 pi I multiply करें. This value is called will be the value of that integration with the help of Cauchy residue theorem. And the application of analytic function find the application in various fields, including engineering and both so many physics, chemistry, and many more places, quantum mechanics. At that we find some complex type of integration. Means अगर simply we can say the role of whole complex analysis is to deal with the solution of integration of real function, and those functions that which are not solved by any so-called method also we try in complex analysis technique, and we find so many times interesting solution, immediate solution, fast solution, and better accurate solution with the technique of complex analysis. So conclusion, The analytic functions are crucial concept in complex analysis. These are the functions that are differentiable within their domain and satisfy the Cauchy-Riemann equation. Analytic functions have many fascinating property and application in various scientific and engineering disciplines. Their study help us better understand the behavior of complex function and solve the complex mathematical problem. Thank you.